given that f of x is given as x squared plus 2x. If you apply the formula which I have dropped previously, you will see that the power becomes down, that is 2 comes down, and the power reduces by 1, so it will be 2x. This 2, the power of x is 1, 1 times 2 is 2, and the power reduces by 1. X raised to power 0 is 1, so it remains this way. But this one is upon capturing this formula. But if you don't know this formula, you are told to get it by the first principle. You apply the first principle formula that says that the f of x is given by f prime of x is given as f of x plus dx minus f of x over dx. So that is what we've substituted. X squared now becomes x plus dx squared. 2x becomes 2 into x plus dx minus f of x, which is actually x squared 2x. Then you divide by dx. If you substitute that in this format, you'll end up that the x squared and the x squared cancels out. 2x and 2x cancels out. You end up with 2x dx plus dx squared plus 2 dx. Then if you divide by everything by dx, dx will cancel this one, divided with 2x. Dx cancels the d squared, remain with dx. Dx cancels this dx, remain with the 2. But dx we are declared approaches 0, so our derivative becomes 2x plus dx. That is the derivative from the first principle. Those one for linear functions and polynomial looks simple and interesting. What about if you have got now a sinusoidal function? For example, now given that f of x is now equal to sine of x. F of x is now equal to sine of x. So from the first principle, the derivative of this function, that is f prime of x, shall be given as sine, let's grab the general form, which is f of x plus h minus f of x over h when h actually approaches 0. So this is the formula for the first principle. So let's replace here so that we can get the derivative. We shall have sine of x plus h minus sine of x, everything over h. When h is actually approaching 0, will give us the derivative of that function. So this is very interesting. If you can see this and you recall what we call the double angle expression of a sine, it becomes, so you expand sine of x plus h in form of a double angle, which becomes sine of x cosine of h plus cosine of x sine of h. That is the expansion of this one into double angle. Then minus sine of x, everything divided by h. When h actually approaches 0, will give us the derivative of that function. So if you have this one, you can take together equations with sine of x together. So you end up with sine of x is a common factor here into cosine of h. Let's not confuse this cosine of h with a cos of a hyperbolic function. Then it goes here -1 times plus cosine of x sine of h. Everything divided by h. So if you do that, you end up with this one will give us the derivative f prime of x when h is actually approaching 0. So you can separate the denominator in form of sine of x into cosine of h minus 1, everything over h, plus cosine of x sine of h, everything over h. So we know that this one will give us the derivative function of x when h is actually approaching 0. So we can substitute at this point. H is 0. What is cosine of 0? Cosine of 0 is 1. 1 minus 1 is 0. So this bracket goes to 0. 0 multiplied by sine x, the first bracket goes to 0. So you end up with f prime of x when h is approaching 0 is given as this part goes to 0. You end up with cosine of x into sine of h over h. But for very small values, this one is called a sinc function. For small values, for very small values of h, of h. Therefore, sine of h over h is actually equal to 1, and this is what we call a sinc function. Sinc function. So if sine of h is equal to 1, so we end up with f prime of x when h is actually approaching 0 is given as cosine of x. So from here, we can make a general deduction that the derivative of a sine of x gives us a cosine of x. So we can conclude that given a function s, f of x is equal to sine of x, then the derivative f prime of x, which is actually the dy over dx, is given as cosine of x, as we proved from the first principle. So we can also prove that given that f of x is given as sine of mx, where m is equal to 1, 2, or 3, 4, such integral values, the derivative dy over dx for such function, which is actually the f prime of x, this one indicates a derivative, shall be given as the coefficient pre-multiplies and it changes to cosine of mx. The coefficient comes to precede, then it changes to cosine of the same variable. So let's have our example D, number D, which is given as f of x is given as cosine of x, to find dy over dx by first principle. So we just know the general formula of first principle, that is f prime of x shall be given as f of x plus h minus f of x, everything divided by h when h is actually approaching 0. So we replace, it shall be cosine of x plus h minus cosine of x, which is our f of x, everything divided by h, and this one will give us f prime of x when we know h is approaching 0. So from this one, we expand cosine of x plus h in terms of double angle, and it becomes cosine of x cosine of h minus sine of x sine of h. That is the expansion of double angle from double angles. Then minus cosine of x, everything divided by h shall give us f prime of x when h is approaching 0. So from there, we can expand it further. Here, let's use here to expand it. We can expand it in this format by collecting terms with cosine of x. So if you collect terms with the cosine of x in that format, you shall get that. We shall get that. We factor this one and the other one. We have got cosine of x common into cosine of h minus 1, then minus sine of x sine of h, this one divided by h, this one divided by h in that format. So cosine of 0 is 0, is 1. So 1 minus 1 is 0. So this first bracket goes to 0. That is, this first goes to 0. So 0 times something, the first bracket goes to 0. You end up with the f prime of x as h approaches 0 is given as negative sine of x sine of h over h. But we know this one is also a sinc function. This is a sinc function which is equal to 1. So we end up with f prime of x is equal to negative sine of x. So we've also proved that given f of x is dy over dx, f of x is given as cosine of x, then dy over dx is given as negative sine of x. But what about case when f of x now is given as cosine of a variable nx? Cosine of a variable nx. The derivative shall be, which is dy over dx of such a function, when n is actually 1, 2, 3 of such integers, the derivative shall be negative sine of nx with n preceding. Negative n sine of nx. The coefficient is multiplied first with a negative sign and the cosine changes to sine. So we now know the derivative of our sine and we can prove it from the first principle. We know the derivative of our cosine from the first principle and the derivative of polynomials and the constant. So we can conclude from there. And for you to master this one, you must remember that sine of a plus b from double angle is given as sine of a cosine of b plus sine plus cosine of a sine of b. This is the double angle expression of compound angle. Also, cosine of a plus b is given as cosine of a cosine of b minus sine of a sine of b. So these are what we use to expand these brackets of double angles for us to get the derivative from the first principle. So we shall stop from there. Stay posted for the next video.